Hello dear students, welcome to my channel that is B Anand Kumar. So ಈ ವಿಡಿಯೋ ನಾನು ಮಾಡ್ತಾ ಇರೋ ಉದ್ದೇಶ ಏನಂತ ಅಂದ್ರೆ ಈಗ ಫಸ್ಟ್ PUC ಆನ್ಯುವಲ್ ಎಕ್ಸಾಮ್ ಬರ್ತಿದೆ. ಸೊ ಫಸ್ಟ್ PUC ಆನ್ಯುವಲ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಈಗ ಫಿಸಿಕ್ಸ್ ಎಕ್ಸಾಮ್ ನೀವು ಫೇಸ್ ಮಾಡಬೇಕು. ಸೊ ಯಾವ ರೀತಿ ಪ್ಲಾನ್ ಮಾಡಬೇಕು, 70 ಔಟ್ ಆಫ್ 70 ತುಂಬಾ ಈಸಿಯಾಗಿ ಸ್ಕೋರ್ ಮಾಡಬೇಕಾದ್ರೆ ಸೊ ಯಾವ ರೀತಿ ಪ್ಲಾನ್ ಮಾಡ್ಕೋಬೇಕು, ಯಾವ ರೀತಿ ಟ್ರಿಕ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಸೊ ಅದ್ರ ಬಗ್ಗೆ ನಾನು ಈ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ನೋಡಿ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಎಲ್ಲರೂ ನೋಡಿರ್ತೀರಾ. ಸೊ ಅದ್ರ ಪ್ರಕಾರ ಒಂದು ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಈಗ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ, ನಿಮಗೆ ಕಂಪ್ಲೀಟ್ ಐಡಿಯಾ ಬರುತ್ತೆ. ಈಗ ನೋಡಿ ಟೋಟಲ್ ನಾವು ಅಟೆಂಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಓನ್ಲಿ 70 ಮಾರ್ಕ್ ಅಷ್ಟೇ. ಆಲ್ಮೋಸ್ಟ್ ಒಂದು 2 hours ಅಲ್ಲೇ ಅದನ್ನು ನಾವು ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಯಾವ ಪಾರ್ಟ್ ನ ಟಚ್ ಮಾಡಿದ್ರೆ ಸೊ ನಮಗೆ ಸ್ಕೋರ್ ಆಗುತ್ತೆ, ಮತ್ತೆ ಮೈಂಡ್ ತುಂಬಾ ಪ್ಲೆಸೆಂಟ್ ಆಗಿರ್ಬೇಕಾದ್ರೆ ಸೊ ಯಾವ ಪಾರ್ಟ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಸುಮಾರು ಜನ ಏನ್ ಮಾಡ್ತಾರೆ, MCQ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಬಿಟ್ಟು ಅದರಲ್ಲಿ ಕೆಲವೊಂದು ಬಲಿಲ್ಲ ಅಂದ್ರೆ ಟೆನ್ಷನ್ ತಗೊಂಡು ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಸ್ ಅಟೆಂಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸೊ ಅದರ ಪರಿಣಾಮ ಇದೆ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಏನ್ ಮಾಡ್ಬೇಕು, ಸೊ ಬೆಟರ್ ನಾನು ಹೇಳೋದು ಫಸ್ಟ್ ಡಿರೈವೇಷನ್ ಫಿನಿಶ್ ಮಾಡಬೇಡಿ. 5 ಮಾರ್ಕ್ ಡಿರೈವೇಷನ್ ಏನಿದೆ ಅದನ್ನ ನಾವು ಈಸಿಯಾಗಿ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತೀವಿ. ಆಲ್ಮೋಸ್ಟ್ 6 ಡಿರೈವೇಷನ್ಸ್ ಇರುತ್ತೆ, ಅಟೆಂಡ್ ಮಾಡಬೇಕಾದ್ರೆ ಓನ್ಲಿ 3 ಅಷ್ಟೇ. ಸೊ ಅದಾದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ 3 ಮಾರ್ಕ್ ಅದು ಕೂಡ ಆಲ್ಮೋಸ್ಟ್ 4 ಚಾಯ್ಸ್ ಇರುತ್ತೆ, ಅದನ್ನು ಈಸಿಯಾಗಿ ನಾವು ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತೀವಿ. ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ, ಸೊ 5 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, 3 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಇವನ್ 2 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ. First 5 mark, along with 3 mark, after that 2 mark. ಅದಾದ್ಮೇಲೆ fill in the blank. ಅದು ಕಂಪ್ಲೀಟ್ ಆದ್ಮೇಲೆ ಕೊನೆಗೆ MCQ, ಅದಾದ್ಮೇಲೆ ಫೈನಲಿ ನ್ಯೂಮರಿಕಲ್ಸ್ ಏನಿದೆ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ. ಸೊ ಈ ತರ ನೀವು ಪ್ಲಾನ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನನ್ಗೆ ಗೊತ್ತಿರೋ ಪ್ರಕಾರ ತುಂಬಾ ಪ್ಲೆಸೆಂಟ್ ಆಗಿ ಹೋಗುತ್ತೆ. ಸೊ 70 ಔಟ್ ಆಫ್ 70 ತುಂಬಾ ಈಸಿಯಾಗಿ ಕೂಡ ಸ್ಕೋರ್ ಮಾಡಿ. ಓಕೆ, ಸೊ ಈಗ ಒಂದು ಮಾಡೆಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಅದರಲ್ಲಿ ಫಸ್ಟ್ ನೋಡಿ ಡೈರೆಕ್ಟ್ ಪಾರ್ಟ್ ಡಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿ. ಆಲ್ಮೋಸ್ಟ್ 6 ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಒಂದು 4 to 5 ಕ್ವಶನ್ಸ್ ಅದರಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿ. ಅದಾದ್ಮೇಲೆ 3 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್, 2 ಮಾರ್ಕ್ ಕ್ವಶನ್. ಸೊ ಯಾವ ರೀತಿ ನೀವು ಎಕ್ಸಾಮ್ ನ ಫೇಸ್ ಮಾಡಬೇಕು. ಸೊ ಈ ವಿಡಿಯೋ ಕಂಪ್ಲೀಟ್ ನೋಡಿದ್ರೆ 100% ನಿಮಗೆ ಪಕ್ಕಾ ಐಡಿಯಾ ಇದೆ. So let us start the question. Today question number 39. This is the most expected derivation. So motion in a straight line ಅಲ್ಲಿ ಇರೋದೇ 2 very important 5 mark. ಒಂದು x is equal to v naught plus half 8 square, better v square is equal to v naught square plus 2x. So ಇದರಲ್ಲಿ ನಾನು v square is equal to v naught square plus 2x using VT graph ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಈಗ ನೀವು ಡಿರೈವೇಷನ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರ್ತೀರಾ, ಸೊ ಮೈನರ್ ಮಿಸ್ಟೇಕ್ಸ್ ಕೂಡ ಇರುತ್ತೆ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕಾದ್ರೆ. ಸೊ ಇನ್ನೊಂದ್ಸರಿ ಹೇಳೋದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ಕೇಳಿಸ್ಕೊಂಡ್ರೆ ಸೊ ಡಿರೈವೇಷನ್ ಆರಾಮಾಗಿ ಕಂಫರ್ಟ್ ಆಗಿ ಮಾಡಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಯುವರ್ ಟೂ ಆಕ್ಸಿಸ್ ನಾನು ಚೂಸ್ ಮಾಡ್ತೇನೆ. ಒಂದು ಎಕ್ಸ್ ಆಕ್ಸಿಸ್, ಒಂದು ವೈ ಆಕ್ಸಿಸ್. ವಿ ಟಿ ಗ್ರಾಫ್ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ, ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ is taken along y-axis and time is taken along x-axis. So here particle starting with initial velocity and moving with uniform positive acceleration. Particle starting with initial velocity and moving with uniform positive acceleration. Graph ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ. Okay. ಈಗ ನೋಡಿ ಆ ಟೈಮ್ t is equal to 0, ವೆಲಾಸಿಟಿ is not equal to 0. ಗ್ರಾಫ್ ಅಲ್ಲಿ ನಿಮಗೆ ತುಂಬಾ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಟೈಮ್ 0 ಇದ್ದಾಗ ವೆಲಾಸಿಟಿ 0 ಇಲ್ಲ. ಸೊ ಏನದು, ದಟ್ ಇಸ್ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ. ಸೊ ಅದು v ನಾಟ್ ಅಂತ ನಾವು ಚೂಸ್ ಮಾಡ್ಕೋಬೇಕು. ಇದು ಬಂದು ಫೈನಲ್ ವೆಲಾಸಿಟಿ, ಏನಾಗುತ್ತೆ ಇದು ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಅಂಡ್ ದಿಸ್ ಒನ್ ಇಸ್ ದ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ. ಅಂಡ್ ಇಲ್ಲಿ ಏನಿದೆ ಇದು ಟೈಮ್ ಆಗುತ್ತೆ. Initially time 0, So ಈ ಪಾಯಿಂಟ್ ಹತ್ರ ನಾವು ಟಿ ಸೆಕೆಂಡ್ ಅಂತ ಚೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಇದು ಕಂಪ್ಲೀಟ್ ಏನಾಗುತ್ತೆ ಟಿ ಸೆಕೆಂಡ್, ರೈಟ್. ಮತ್ತೆ ನೋಡಿ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆಲ್ಲ. ಸೊ ಇದು ಬಂದು ಇದು ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ. What is it? Change in velocity. This is initial velocity, so this is final velocity, and this is change in. Let us consider here initial velocity v naught, final velocity v, and change in velocity is v minus v. Now O, A, B, C, D, and the children, right? Let us consider this angle theta. Okay. So ಈಗ ಫಸ್ಟ್ ನಾವು average velocity equation ತಗೋಬೇಕು. So average velocity ಏನು ಬರುತ್ತೆ? V plus V naught divided by 2, and call this is equation number 1. And average velocity that can also be written in the form of x by t, so rate of change of displacement, and x is equal to v bar into t. So by using your first kinematic equation kuda use ಮಾಡಬೇಕಾಗುತ್ತೆ. By using v is equal to v naught plus at, v is equal to v naught plus at. So t is equal to v minus v naught divided by a. So t is equal to v minus v naught divided by a. So all this is equation number 2. And all this is equation number 3. Now equations 1 and 3 and equation 2. Equation 2 ಅಲ್ಲಿ 1 and 2, 1 and 3 ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. So x is equal to v bar is v plus v naught by 2, v plus v naught by 2, into t andre, so that is v minus v naught divided by a, just cross multiply ಮಾಡಿ. So 2ax is equal to today v plus v naught into v minus v naught, a plus b into a minus b formula ಇದೆ. So now v square minus v naught square ಅಂತ ಬರೀಬಹುದು. So finally we will get ಇದನ್ನ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಬೇಡಿ, v square is equal to v naught square plus 2ax. So this is actually the third kinematic equation. So nothing according to scheme of valuation is more than sufficient. So diagram ಗೆ graph ಏನಿದೆ, so ಇದಕ್ಕೆ 1 mark ಇರುತ್ತೆ. So graph ಇಲ್ದಿರ ನೀವು derivation ಮಾಡಬೇಕು. Graph ಗೆ 1 mark ಇರುತ್ತೆ. So derivation ಗೆ 4 mark. So 4 ಗೆ complete 4 mark. This matter, right? Next derivation. Obtain an expression for the magnitude and direction of resultant of two vectors. Resultant of two vectors A and B in terms of their magnitude and angle theta between them. So this is also the most expected repeated 5-mark derivation. So the motion in a plane chapter element. Okay. Derivation not correct. Where is saying for derivation? Easy as you are some answer. let us draw two vectors. There's a vector and another one is b. So both are acting at the same point. So it is a vector, b vector, anyway. So both are acting at the same. Change ಮಾಡ್ತೀವಿ. ಈಗ ಒಂದು ಪ್ಯಾರಲೋಗ್ರಾಮ್ ಈಗ ನಾನು ಡ್ರಾ ಮಾಡಿದ್ದೀನಿ. Parallelogram, right? Let us consider parallelogram of O A B C. ಈಗ actually ನಾವು ಒಂದು perpendicular draw ಮಾಡಬೇಕು. Diagram is very very important. Correctly careful ಆಗಿ draw ಮಾಡಬೇಕಾಗುತ್ತೆ. ಈಗ ನೋಡಿ ನಾವು ಒಂದು perpendicular draw ಮಾಡ್ತೀವಿ. So OC line ಗೆ so ಈ line ಏನಿದೆ exactly perpendicular ಇದೆ. So ಇದನ್ನ ನಾವು B C ಅಂತ choose. So draw BD, so that is perpendicular to OD. Let us consider this angle as theta. So theta is the angle between two vectors. Two vectors are one is A vector and another one is B vector. So statement error ಗೊತ್ತಿರುತ್ತೆ. If two vectors acting at a point represents both in magnitude and direction by the two adjacent sides of a parallelogram, both are drawn from the same point. Then the resultant is represents both in magnitude and direction by the diagonal of the parallelogram, and that is drawn from the same point. Okay. Guys, a very good example catapult, caterpillar ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಒಂದು ರಬ್ಬರ್ ಬ್ಯಾಂಡ್ ಇರುತ್ತೆ, ಹೀಗೆ ನಾವು ಸ್ಟ್ರೆಚ್ ಮಾಡಿದಾಗ tensions create ಆಗುತ್ತೆ. Okay, tension is always along the string away from the object ಇರುತ್ತೆ. ಸೊ ಯಾವಾಗ ನಾವು ಹೀಗೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಬಿಟ್ಟು ಹೀಗೆ ಫುಲ್ ಮಾಡ್ತೀವಿ, ಸೊ ಒಂದು ಟೆನ್ಷನ್ ಹೀಗಿರುತ್ತೆ. ಸೊ ಎ ವೆಕ್ಟರ್ ಅಂತ ನಾವು ಅನ್ಸ್ಯೂಮ್ ಮಾಡ್ಕೋಬಹುದು. ಅನದರ್ ಒನ್ ಇಸ್ ಬಿ ವೆಕ್ಟರ್. ಸೊ ಇಲ್ಲಿರೋ ಆಬ್ಜೆಕ್ಟ್ ನ ಜಸ್ಟ್ ರಿಲೀಸ್ ಮಾಡಿದ ತಕ್ಷಣ ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಅಲಾಂಗ್ T1 T2 ಹೋಗೋದಿಲ್ಲ, ಅದು ಅಲಾಂಗ್ ದ ಡಯಾಗ್ನಲ್ ಹೋಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ರಿಸಲ್ಟೆಂಟ್ ಅಲಾಂಗ್ ದ ಡಯಾಗ್ನಲ್ ಹೋಗುತ್ತೆ. Let us consider here the resultant this is the resultant, right? R. R vector is the resultant of A vector and B vector. Let us consider alpha. Alpha is the angle made by direction of resultant with A vector. So this is angle theta. What about this angle? So this is also theta. Yakandre these two are corresponding. Angle AOC ಮತ್ತು angle BCD ಎರಡು ಸೇಮ್ ಆಗಿದೆ because those two are corresponding. ಈಗ derivation ಹೋಗ್ತೀವಿ. ಈಗ ಒಂದು ಕೆಲಸ ಮಾಡೋಣ. First let us consider here OA is nothing but B here and OAB ಆದ್ರೆ diagram ನೋಡಿ CB ಕೂಡ ಏನಾಗುತ್ತೆ B ಆಗುತ್ತೆ, right? And then OC andre that is A. OB is nothing but R. OB is R. So ಇಲ್ಲಿ ನಾವು Pythagoras theorem first apply ಮಾಡಬೇಕು. So in the triangle OBD, so OB square is equal to OD square plus in BD square, OB square plus BD square. So OD under now OC plus CD under mentioned, right? OB square is equal to OD means what? OC plus CD whole square plus B square. So OB square is equal to A plus B whole square formula use ಮಾಡಬೇಕು. OC square plus CD square plus 2 into OC into CD plus ಏನು ಬರುತ್ತೆ CD square. Okay. So ಇಲ್ಲಿ ನೋಡಿ ಈಗ OB ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ನಾನು ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೀನಿ. OB is nothing but or OB is or. Okay. OC andre OCA, okay, right? ಮತ್ತೆ the triangle BCD observe ಮಾಡಿ, the triangle BCD. So ಆ triangle ಅಲ್ಲಿ cos theta ಏನು ಬರುತ್ತೆ base divided by hypotenuse. Base is CD, so base is CD. So hypotenuse ಬಂದು CB ಅಂದ್ರೆ what is that? B. So CD by B. So CD value ನಮಗೆ B cos theta ಬರುತ್ತೆ. So same triangle ಅಲ್ಲಿ sin theta find ಮಾಡ್ಕೋಬೇಕು. Sin theta ಏನು ಬರುತ್ತೆ perpendicular divided by hypotenuse. So perpendicular ಬಂದು BD. Hypotenuse is CB. CB is nothing but what? B. So BD is equal to B sin theta. So ಇದನ್ನ equation ಅಲ್ಲಿ substitute ಮಾಡೋದು. So then we will get R square is equal to OC square andre A square plus CD square andre B square cos square theta plus 2 into OC is A, right? CD is B cos theta plus BD square is B square sin square theta. B square sin square theta. So R square is equal to A square plus B square of cos square theta plus sin square theta. The two terms are now B square common things anyway. So sin square theta plus cos square theta goes to 1 plus 2AB cos theta, and finally we will get R is equal to square root of square root of A square plus B square plus 2AB cos. So this is the magnitude of resultant of two actors acting at the same point. And direction calculate ಮಾಡೋದು very simple. So ಈಗ ನೋಡಿ again triangle OBD observe ಮಾಡಿ. So ಈ triangle ಅಲ್ಲಿ tan alpha ಏನು ಬರುತ್ತೆ BD divided by OD ಅಂದ್ರೆ OC plus CD. So BD value ಇಲ್ಲೇ ಇದೆ. So that is B sin theta divided by OC is nothing but A, okay, plus CD is nothing but B cos theta. So finally alpha is equal to tan inverse of B sin theta divided by A plus B cos theta. So this is the angle made by direction of resultant with K by. So this is magnitude of resultant of two vectors acting at the same point, and this is the angle made by direction of resultant with. And this is a very important derivation. Even ಇದು ನಿಮಗೆ next second year ಕೂಡ ತುಂಬಾ next ನೋಡಿ state and through the conservation of mechanical energy for speeding falling body under gravity. This is also very simple derivation. So conservation of mechanical energy statement the total mechanical energy of an isolated system is always constant. That means the energy can neither be created nor be destroyed but it can be transferred from one body to another. Statement almost ಎಲ್ಲರೂ ಗೊತ್ತಿರುತ್ತೆ. So ಇನ್ನೂ ಒಂದ್ಸರಿ ಹೇಳ್ತೀನಿ ಕರೆಕ್ಟಾಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. The total mechanical energy of an isolated system is always constant. That means the energy can neither be created nor be destroyed, but it can be transferred from one body to another body. So derivation is very simple. Let us consider a ball, spherical ball, is dropped from certain height. Certain height in the spherical ball in the drop onto the drop from certain spherical ball in the so of all the three locations which will be so drop ಆಗ್ಬೇಕಾದ್ರೆ so starting from rest, so this is the initial location of the ball A and the Q, and then so B and the C, and this is finally ball hits the ground. Okay, ball hits the ground. So location C and the Q. Right, so the distance from complete height h. H is the height of the ball from the surface of Earth. So A to B, so x and the x are the remaining distance in a so in h minus x. Right. Okay, here. Wait, what is this? H. It is the x. So this is h minus h minus. ಈಗ ನೋಡಿ total energy at A, B, C actually same ಇರುತ್ತೆ ಅಂತ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. First at point A. At point A, so what is the potential energy at point A? Potential energy in mg square. So kinetic energy at point A is equal to 0. Total energy at point A is equal to the sum of kinetic energy and potential energy. So kinetic energy is 0. So potential energy is mgh. So total energy at point A, so we will get mgh for the one. And at point B, so the motion takes place from what is moving from A to B. So what is moving from A to B. So initial velocity of the body, so that is 0. And if it reaches the point B, the velocity is Vb and it is moving downwards. So A becomes flat G and the displacement S is equal to X. So now by using third kinematic equation, V square is equal to V naught to X, knowing the derivation. So V square is equal to V naught plus 2AX. Actually here V naught is 0. Initial velocity is 0. So V square is equal to V naught square plus 2AX and the use marble. V square is equal to V square plus 2AX. Both are same. So VB square under another VB square is equal to 2 A becomes G, X under displacement. So that is S. S V square under V square is equal to U square plus 2AX. So this term goes to 0. VB square is equal to 2gx. So kinetic energy at point B is of m VB square. So this is of m. VB square is 2gx. So 2 get cancelled here. So kinetic energy at point B is mgx. So potential energy at point B, ನೋಡಿ height h minus x ಇದೆ. That is why mg of h minus x ಬರುತ್ತೆ. So total energy at point B. So is the sum of kinetic energy at point B plus potential energy at point B. So kinetic energy at point B is mgx plus potential energy at point B, mgh minus mgx. So mgx get cancelled. So EB is equal to finally we will get mgh, and all this is equation number 2. And finally at point C, so the motion takes place. What is moving from where to where? From B to C. We complete A to C and this will be what is moving from A to C. A to C. So here the initial velocity starting from A and the initial velocity is 0 ಆಗುತ್ತೆ, and what is moving downwards A is equal to plus G, and the displacement S is equal to H. So velocity at point C, so V is equal to Vc, again by using the same formula, V square is equal to U square plus 2AS, and this term goes to 0, so V becomes Vc, so Vc square is equal to 2, A becomes G, S becomes H, and kinetic energy at point C is of m Vc square, so that is equal to of m Vc square is 2gh, and 2 cancels here, and finally we will get mgh. So potential energy at point C is 0. When the ball reaches the ground ಗೆ reach ಆಗಿದೆ ಅಂದ್ರೆ h 0 ಆಗುತ್ತೆ, h 0 ಆದರೆ potential energy is 0. So total energy at point C is sum of kinetic energy and potential energy. Okay, so kinetic energy is mgh and potential energy is 0. So total energy is mgh, and all this is the equation number 3. So from 3 equations 1, 2 and 3, we can conclude that the total mechanical energy of an isolated system in one dimension is always constant. So when the ball is moving from A to B, actually the potential energy gradually decreases in the direction, in this direction of gravitational force, potential energy decreases, but kinetic energy increases. So when it reaches the ground, the complete potential energy is converted into kinetic energy. This is very important. So I'll get 3 very important derivations. So 3 parts in this question. Now on the 2 derivations discussed now. So explain angular momentum in case of a rotation about a fixed axis. Prove the time rate of change of angular momentum of the particle is equal to torque acting on it, equal to torque acting. First, what is the meaning of angular momentum? The angular momentum andre moment of momentum about the axis of rotation. Is the meaning of angular momentum? Moment of momentum about the axis of rotation. So ಇಲ್ಲಿ ಒಂದು ಸರ್ಕ್ಯುಲರ್ ಡಿಸ್ಕ್ ನಾನು ಚೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಒಂದು ಆಕ್ಸಿಸ್ ನೋಡಿ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ exactly at the center. Okay, that center ಅಲ್ಲಿ ಪಾಸ್ ಆಗಿದೆ. ಇದು ಬಂದು ರೇಡಿಯಸ್ ವ್ಯಾಕ್ಟರ್ ಆಗುತ್ತೆ. Okay, ಇದು ಬಂದು ರೇಡಿಯಸ್ ವ್ಯಾಕ್ಟರ್ and ಇದು ಬಂದು linear momentum. So R vector, actually linear momentum is directed into the plane of the screen. Okay, so linear momentum is into the plane of this. That answer, this one is R vector, this is P vector, this is the axis of rotation. The angle between R vector and P vector is exactly equal to 90 degree. And P vector is inverse, and this is M into V vector. The angular momentum and the momentum about the axis of rotation. Angular momentum is moment of momentum about the axis of rotation. So that is called the angular momentum. Momentum about the axis of rotation. So the formula, not a L vector is equal to angular momentum is measured by taking the cross product of two vectors, so radius vector and linear momentum vector, and the magnitude is Rp sine theta. So R is the radius, P is the linear momentum, theta is the angle between theta angle between R vector and P vector. So if R vector is perpendicular to P vector, so then theta is equal to 90. So then angular momentum is actually maximum. So ಇದಕ್ಕೆ actually 2 marks ಇದೆ. So ಅದಾದ್ಮೇಲೆ statement ಗೆ 1 mark ಇದೆ. So equation ಗೆ 1 mark. So prove the time rate of change of angular momentum of the particle is equal to torque acting on it. So this is actually very important and repeated 5 marks if you could have said. So the same equation, L vector is equal to R vector cross P vector. So differentiate with respect to time on both sides. And hopefully dl vector divided by dt is equal to d divided by dt of R vector cross P vector. So dl vector divided by dt is equal to, ಈಗ ನೋಡಿ ಪ್ರಾಡಕ್ಟ್ ರೂಲ್ ನಾವು ಯೂಸ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಟರ್ಮ್ ಹಾಗೆ ಇಟ್ಕೋಬೇಕು, ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಗೆ ಡಿಫರೆನ್ಶಿಯೇಷನ್ ಆರ್ ವೆಕ್ಟರ್ ಕ್ರಾಸ್ dt vector by dt ಪ್ಲಸ್, ಸೊ ನೆಕ್ಸ್ಟ್ ಫಸ್ಟ್ ಟರ್ಮ್ ಗೆ ಡಿಫರೆನ್ಶಿಯೇಷನ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಹಾಗೆ ಇಟ್ಕೋಬೇಕು. ಕ್ರಾಸ್ P vector means m into P vector. So R vector cross dt vector divided by dt, rate of change of momentum is force. This is according to Newton's second law. Dr by dt, rate of change of displacement is velocity vector. So V vector cross m into V vector. So R vector cross F vector is nothing but torque. Torque means turning effect produced by the force and is measured by taking the cross product of radius vector and the force vector. So here m is scalar, take it as outside, remaining V vector cross. So this is not into V vector cross V vector. So this entire term goes to 0. Cross product of two same vectors is 0. V vector cross V vector andre V vector is parallel to V vector agutte and theta is 0. So V square sin 0 is 0 agutte. So this term goes to 0. And finally rate of change of angular momentum exactly equal. So this is also very simple. You put on your maybe derivation not good. One more derivation. So one derivation method. Almost 2 extra questions discussed. ಸ್ವಲ್ಪ brief explanation time ಜಾಸ್ತಿ ಇದು ತುಂಬಾ ಇದೆ. Explain modes of vibration of air column in closed pipe. Modes of vibration of air column in open pipe, closed pipe. The open pipe ಇಲ್ಲ closed pipe ಎರಡು ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಎರಡರಲ್ಲಿ ಒಂದು derivation ಬರೋ ಚಾನ್ಸಸ್ ತುಂಬಾ ಇದೆ. So closed pipe andre meaning in so a pipe which is closed at one end, open at another. Closed at one end, open at another. That is nothing but closed. So at open end, the particles are free to vibrate with maximum amplitude. So we will get anti-node point. So at closed end, the particles are not free to vibrate with maximum amplitude. So we will get node point. So when the tuning force or the excited tuning force is different, not the vibration. So it is a forcing like this. Right? So really length in it is length lambda by 4. L is equal to lambda 1 by 4. So lambda 1 is equal to 4m. So in the fast mode, so fast mode, we get one node and one antinode. One node and one antinode. So V is equal to F lambda formula. V is equal to F lambda. So we have a fundamental frequency. So F1 is equal to V divided by lambda. The formula for V is equal to F lambda. F is equal to V by lambda. So V divided by lambda 1 is 4F. So this is the fundamental frequency, the first form. This is fundamental frequency of closed pipe and first form. First form. Okay. So in the second mode only, the lambda by 4 distance increase. Okay. Second mode get 3.9. Length actually the lambda by 2, so it will get lambda by 4. So this is L is equal to lambda 3 lambda 2 by 4. So lambda 2 value 4L by 3. So this is second mode. In the second mode, we get two nodes and two antinodes. These are antinodes, node N1 and two nodes A1. These are antinodes. Okay. So again here the frequency F2 is equal to V by lambda 2. So V divided by lambda 2 is 4L by 3. So F2 is equal to V by 4L is F1. Is it right? V by 4L is F1. 3 times F1 by F. And this is the third harmonic. So third harmonic. Now the second harmonic is really mixed agate. So hence closed pipe is not used for making musical instruments. Musical instrument ಮಾಡಬೇಕು ಅಂದ್ರೆ ಎಲ್ಲ ಹಾರ್ಮೋನಿಕ್ ಪ್ರೆಸೆಂಟ್ ಆಗಿರಬೇಕು ಬಟ್ ಇದರಲ್ಲಿ even harmonic lift ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನು ನಾವು ಮ್ಯೂಸಿಕಲ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಆಗಿ ಮಾಡೋದಕ್ಕಾಗುತ್ತೆ. ಥರ್ಡ್ ಹಾರ್ಮೋನಿಕ್ ಆರ್ ಫಾಸ್ಟ್ ಓವರ್ ಫಾಸ್ಟ್ ಓವರ್ third. It is also very simple harmonic note. Each point in the each point is lambda. So this is lambda by 4. So lambda plus lambda by 400, almost 5 lambda by 4. So lambda 3 is the 2. Lambda 3 is 4L by 5. But, lambda 3 is 4L by 5. And 5 lambda 3 by 6. So third node, you will get how many nodes? 3 nodes. Correct? You will get 3 nodes and 3 antinodes. A1, A2. So antinode means particles are free to vibrate with maximum amount. So node point only particle vibrator, but antinode only particles free vibration. So with maximum. So in the third mode, we get 3 nodes and 3 antinodes. Okay, so same formula V is equal to F lambda. F3 is equal to V is equal to F by lambda 3 velocity. So F3 is equal to V divided by lambda 3 means 4L by 5. F3 is equal to 5 times F1. Right? So this is 6th term. Okay. Or second over. So ಈಗ ratio F1 F2 to F2 3 F2 so on. So that is 1 H2 3 H2 5 H2. Generally only odd harmonic matra. So even harmonic is fine. First one will complete 5 mark. It is very simple explanation. Easier ನೀವು exam ಅಲ್ಲಿ ಬರೆಯಬಹುದು. ಈಗ ನೋಡಿ part C. So part D ಅಲ್ಲಿ 5 mark derivations almost 3 ಮಾಡಬೇಕು. ಇನ್ನು ಒಂದು 2 questions extra ನಾನು ಹೇಳಿದ್ದೀನಿ. So next 3 mark ಅಲ್ಲಿ 5 questions ಮಾಡಬೇಕು. So ಇದರ ಒಂದು 2 extra questions ಅಟೆಂಡ್ ಮಾಡಿದ್ರೆ ಸಪೋಸ್ ಏನಾದರೂ ನೀವು ಅಟೆಂಡ್ ಮಾಡಿರೋ questions ಅಲ್ಲಿ ಸೊ ಅದರಲ್ಲಿ ಅದು ಕವರ್ ಆಗುತ್ತೆ. ನೋಡಿ ಫಸ್ಟ್ question number 30. What is meant by projectile? What is meant by projectile? Give an example. What is the shape of the path followed by projectile? So it is very simple. Projectile means there is an object thrown in space with some initial velocity. And the object is allowed to fall under the effect of gravity. So example, a ball kicked from the ground level. So in Barate, path followed by projectile, parabola. In a javelin thrown by a man. So in that case also, path followed by the projectile is parabola. Okay. The projectile is an object thrown in space with some initial velocity. An object is allowed to fall under the effect of gravity alone. Okay. ನೋಡಿ 3 mark question ಎಷ್ಟು ಸಿಂಪಲ್ ಆಗಿರುತ್ತೆ ಆರಾಮಾಗಿ ನಾವು next state Newton's third law of motion. Mention any two important points about the Newton's third law. Newton's third law, so to every action there is an equal and opposite reaction. Every action, so there is an equal and opposite reaction. So let us consider here the two balls moving in opposite direction. If they are collides with each other, collides with each other. ಎರಡು collide ಆಗಿದೆ ಅಂದ್ರೆ ನೋಡಿ force acting on first ball due to second ball, at the same time force acting on second ball due to the first ball. Is it right? Let's consider this ball as A, this ball as B. So this is force acting on A due to B, FAB vector, and this is force acting on B due to A, FB vector. So according to Newton's third law, so FAB vector is equal to minus FBA vector. So both forces having equal value but direction is opposite. Actually, this is action and this one is reaction. The action other is a reaction. Action, reaction, both are force. Action is a force, reaction is also force. Value same but direction is opposite. The 2 points mentioned ಮಾಡಿದ್ರೆ ಸಾಕು. ಮತ್ತೆ very important ಏನಪ್ಪ ಅಂದ್ರೆ action reaction not acting on the same body. ಈಗ ಒಂದು ಬಾಡಿ ಮೇಲೆ ಆಕ್ಷನ್ ಇದೆ ಅಂದ್ರೆ ಇನ್ನೊಂದು ಬಾಡಿ ಮೇಲೆ ರಿಯಾಕ್ಷನ್ ಇದೆ. ಒಂದೇ ಬಾಡಿ ಮೇಲೆ ಆಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ ಇರೋದು. It is very important. Action reaction not acting on the same body. Action reaction both are forces. Okay, but action reaction will not cancel with each other. ಎರಡು ಈಕ್ವಲ್ ಅಂಡ್ ಆಪೋಸಿಟ್ ಆದ್ರೂ ಒಂದೇ ಬಾಡಿ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಈಕ್ವಲ್ ಅಂಡ್ ಆಪೋಸಿಟ್ ಫೋರ್ಸಸ್ ನೆಟ್ ಫೋರ್ಸ್ 0 ಆಗುತ್ತೆ. ಬಟ್ ಸೊ ಹಿಯರ್ ಆಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ ಆಕ್ಟಿಂಗ್ ಆನ್ 2 different ಬಾಡಿ. ಸೊ ಇದು ಈಕ್ವಲ್ ಅಂಡ್ ಆಪೋಸಿಟ್ ಇದ್ರು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So this point is also very important. Okay, so this is about Newton's third law and very important points about Newton's third law. There are 2 questions is there complete. So what are conservative force and non-conservative forces? And give an example. Conservative force andre work done by force does not depend on path taken. Depends only on initial and final position. So that is conservative force. Non-conservative force means work done by force depends on path taken between initial and final position. So that is the non-conservative force. Okay. For example, the object from A to E position move. Object is moving from A to E. A to E move on the object. So under gravitational force, A to E move agade through a distance h and so ಇಲ್ಲಿ work done in ಬರುತ್ತೆ mgh. Work done is mgh. So the same body is moving from A to B, B to A to B, B to C. Next C to C, D to E. So ಹೀಗೆ different path ಅಲ್ಲಿ ಅದು ಮೂವ್ ಆದ್ರೂ ಕೂಡ okay A to B, B to C, C to D, D to E. Okay. ಇಲ್ಲಿ path different ಇದೆ, but final ಆಗಿ initial and final position. ಆಗಲೇ initial and final position ಏನಿತ್ತು. So second case ಅದು initial and final position same. Okay, same ಇದ್ದಾಗ work done same ಇರುತ್ತೆ MGH. ಇಲ್ಲಿ ನೋಡಿ work done in moving the object from B to C actually zero ಬರುತ್ತೆ because gravitational force acts downwards, displacement ಹೀಗೆ ಬರುತ್ತೆ. So displacement perpendicular to force ಅಂದ್ರೆ so work done zero. Okay, ಇದು ಅಷ್ಟೇ from D to E ಹೀಗೆ ನಾವು ಮೂವ್ ಮಾಡಬೇಕಾದ್ರೆ so force acting downwards, displacement work displacement ಏನಿದೆ ಅದು force vector ಗೆ perpendicular ಬರುತ್ತೆ. So ಅದಕ್ಕೆ work done zero. ಓಕೆ ಸೊ ಅಂದ್ರೆ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಏನಿದೆ ಅದು ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್ ಅಂತ. ನಾನ್ ಕನ್ಸರ್ವೇಟಿವ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ವರ್ಕ್ ಡನ್ ಬೈ ಫೋರ್ಸ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಆನ್ ಪಾತ್ ಟೇಕನ್. ವರ್ಕ್ ಡನ್ ಬೈ ಫೋರ್ಸ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಪಾತ್ ಟೇಕನ್ ಬಿಟ್ವೀನ್ ಇನಿಷಿಯಲ್ ಅಂಡ್ ಫೈನಲ್ ಪೊಸಿಷನ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಿಂಪಲ್ ಆಗಿ ಪಾಯಿಂಟ್ ಎ ಟು ಪಾಯಿಂಟ್ ಬಿ. So the object A to B move. Next B to A move. This is W1 and the 2. Work done in moving the object from A to B is W1. Work done by force. If an object moving from B to A is W2. So ಇಲ್ಲಿ ನೋಡಿ W1 plus W2 is not equal to 0. Okay. So ಇಲ್ಲಿ object A to E move ಮಾಡಿ next E to A move ಮಾಡುತ್ತೆ. Object is moving from A to E plus object is moving from E to E. Okay, work done in moving the object from A to E under gravity and work done in moving the object from E to A under gravity. ಎರಡು add ಮಾಡಿದ್ರೆ actually you will get zero. Actually ಇದನ್ನ ನಾವು ಒಂದು round trip ಅಂತ ಹೇಳ್ತೀವಿ. For one round trip, so your net work done is zero. So ಇಲ್ಲಿ for one round trip, net work done is not equal to zero. So work done by force does not depend on path taken, depends only on initial and final position. That is conservative force. Example: gravitational force, magnetic force, free force. So ಇದೆಲ್ಲ example ಕೊಡಬಹುದು. For one round trip, so in this case, for one round trip, the net work done is zero. So ಇಲ್ಲಿ non-conservative force, work done by force depends on path taken between initial and final position. That is non-conservative force. For one round trip, the net work done is not equal to zero. So the example: viscous force, ಮತ್ತೆ frictional force, air resistance. So they are non-conservative force. They'll get 3 questions coming, right? Small numerical element. To maintain a rotor, to maintain a rotor at a uniform angular speed of 200 radian per second, an engine needs to transmit a torque of 180 Newton meter. What is the power required by the engine? Assume that the engine is 100% efficient. The problem solved. First, what is given? It is very important. To maintain a rotor, a uniform angular speed, omega is okay, and torque power find out money. So this is very simple. Power required is for linear motion. Power is the rate of doing work. Work is force into displacement by time. S by T and the V into V. For rotational motion, rotational analog of force is torque. Rotational analog of V is omega. The power required required is here tau into omega. So power is equal to tau. Tau is given, that is 118, 18 into 10, and omega omega is 200. 2 into 10 for 2. So power is equal to 18 to the 36 into 10 for 3. 10 for 3 at, so power is equal to 36 kilo. Okay, that's all. What is the simple? That's a 3-mark question. Next question number 34. State and explain Hooke's law is an example of elastometer. So this is also very simple question. It is not very complete. But ಈ part ಅಲ್ಲಿ 5 questions discuss ಮಾಡಿದ್ದಾರೆ. State and explain Hooke's law. So within the elastic limit, stress is directly proportional to strain. Stress is directly proportional to strain. So stress divided by strain is a constant. So that is E is constant. E is called modulus of elasticity. Statement ಗೆ 1 mark ಇರುತ್ತೆ ನೋಡಿ, equation ಗೆ 1 mark ಇರುತ್ತೆ. Given an example of elastometer ಗೆ example ಬಂದು natural. So this is also very simple. Okay, thank you. Almost 3 mark ಅಲ್ಲಿ 5 questions discuss ಮಾಡಿದ್ದೇನೆ. 5 mark ಅಲ್ಲಿ almost 4 questions ಮಾಡಿದ್ದೇನೆ. ಅಲ್ಲಿಗೆ 15 plus 15 ನೋಡಿ, 15 plus 15 30 mark cover ಆಗುತ್ತೆ. So next 2 mark ಮತ್ತೆ MCQ, fill in the blank. So ಇದೆಲ್ಲ ಇನ್ನೊಂದು ವಿಡಿಯೋದಲ್ಲಿ. Okay, thank you so much.